Desmo, student.desmos.com and type in the code, or you can click on the link. The link might open in Internet Explorer, and you may be better off pasting it in another browser though. So. All right, so just to show you the teacher view, I'm going to pick the level of experience one so that I'm not, you know, if you're having a bad day and you don't want everyone to see how you're feeling, I'm not going to show everybody's responses on that. But on the teacher side, I can see everyone's responses. As far as the level of experience, if I look at the teacher view, I can see the individual responses for that. So it looks like most of you are saying you're down toward the novice end. So hopefully you'll get something out of this. If anybody had put that they were at the expert, then, you know, or closer to the expert, then you might have some things to add at the end of it. And there is a slide at the end where you can make suggestions about other things that teachers might want to know that haven't been included in this presentation. Because with only, you know, 55 minutes presentation, we're not going to cover everything possible for Desmos. We're going to get through what we can to hopefully try to introduce you to that. And then on slide 4, after you entered your name, you should have been able to see other people's responses. So I see we have kind of a mixture of middle and high school teachers included. Those of you who are still working on those slides, that's fine. I'm going to go ahead and open the next couple of slides for us to start looking at our mission and our plans for today while you're completing that. So our mission, district-wide, our mission is to provide educational excellence for all students. And to make sure that all students are well-rounded and prepared for the future. Our norms for today, I hope you will participate actively in the session. Please do mute your microphone unless there's a reason for you to speak so that we're not getting background noise from various schools. And of course, be courteous. Our plans for today, the session is intended to address the strategic goal of increasing the capacity of staff to deliver and support high quality instructions. That's one of the district's 4 main strategic goals, or falls under one of the 4 strategic goals. So the question we want to answer as we go through this session, how can we use tools available in Desmos to help our students learn math? Our target is for you to be able to say at the end that you understand what tools and resources are available that might be useful and that you can use those tools to deliver high quality instruction. We'll know if we've met that learning target if at the end of it you can make these statements. As our opener, we looked at some Desmos starter screens. During our work session, we're going to explore the tools that are available on the various Desmos calculators and consider how those tools might be applied in our secondary math classes. And we're going to identify, hopefully we'll have time at the end to identify some specific activity resources that are already out there that we might find useful. And then for our closing, you'll have screens where you're asked, what did you learn? What are you going to use from that? What more do you still want to learn? All right, so Desmos, and I'm on slide 7 now. So if you're a little behind, that's okay. You can just listen. So Desmos, if you just click in, if you just put desmos.com on your search, then it's going to pop up so that it shows the graphing calculator. But if you click the math tools at the top, there are actually several different calculators available to you through Desmos. The graphing calculator is one of them, but there's also a scientific calculator if you wanted your students to familiarize themselves more with what would be on a scientific one that and without the graphing features that are available. There's your basic 4-function, really 5-function calculator because it has the square root key too. There's a matrix calculator. There's a geometry tool. And then there's a test practice link that takes you to testing versions of it where you can click on your state or your test and see, is there a version of Desmos included on that state test? And if so, what tools does it have available? Because sometimes the state test tools might have been modified slightly from what's on the standard version. All right, so we're going to take the next few minutes, about 6 minutes, and take a look at those 4 types. I'm going to go through each one on my screen and just sort of point out some things, but if you prefer to explore them on your own, then just turn off the speaker for now, and for about the next 6 minutes, just take your time, explore the different calculators. There are links on slides 9 through 12. We're going to then come back together at about 1:19 and talk about the graphing calculator together. So if you're going to follow along with me, then we're about to look first at the 4-function calculator. So the 4-function calculator, and if you want to come back to the Zoom screen, you can follow along, or you can click on it in your own screen. It's up to you. So the 4-function calculator is just what it looks like. You've got your basic 4 operations, square root function, parentheses. You can do your basic computations just like you could with a handheld calculator. Maybe a little different from just like the dollar store kind of 4-function calculators. It will store your answer for the previous one rather than having to clear everything out. So that's the 4-function calculator. It's pretty straightforward. On the scientific calculator, you've got your main menu with the operational tools. You've got your powers, your absolute value, roots, both square root and nth root, a pi key that's going to give you, a better estimation of pi than 3.14, your basic trig functions, parentheses, and so on that main percent, fraction, all of that's available. If you look under the ABC menu on there, you've got your QWERTY keyboard. But functions is where some really cool things are. Not only do you have sine, cosine, and tangent, you have the inverse trig functions here. And then some of you middle school teachers who are teaching some of the statistics concepts like mean and median and mode, you can put in mean, standard deviation is probably not going to be as useful to you. And then the rounding one is kind of cool as well. So if I just put in, say, a data set, and I can do it 2 ways. I can put mean, and then I can just type my data set in the parentheses, and it'll keep a running total of my data, the mean of my data. I can convert it to a fraction. My other option, I can put in a set and just label it with something like A. It creates that 4-element, and then instead of having to type the set in for any calculations, I can just put that I want to find the mean of that set that I labeled. So that's a couple of different ways you can put it in and use the statistics tools. So I think that's pretty. And then for your students who struggle with rounding, this can give them a way to check it. If I say, for example, that I want to round the decimal, that's showing up on my calculator. Right now, if I don't put anything else, it's going to round it to the nearest whole number. But if I wanted it to round to something else, I can put comma and then tell it how many decimal places I want. So like I want to go to the nearest 1,000, 3 decimal places, I can put the 3. Excuse me. Or I can change that and tell it, no, I just want 2 decimal places. And it'll help students that are struggling with that concept of when to round down, when to truncate, when to round up. It'll help them with that. If we look at the geometry tools that are available, you have things, I can make a point, I can make a line segment from one point to another. I can make a infinite line, array, all of that's available. Under more tools, you can use a compass. You can find the midpoint of a segment, label it, create parallel lines for lines that you've drawn, perpendicular lines. So there are a variety of things on the geometry tools. Now, there may be better geometry tools out there, Geometry Sketchpad, but this does have geometry tools available to you. Okay. Then the last one, sorry, I had it open on 2 tabs. I guess I need to close it on one. The last one, just for a quick overview, it also has this cool matrix calculator. So those of you teaching pre-cal that are teaching about matrices, this tool is there for your students to use. Those of you teaching Algebra 2 currently, if you're sticking with us for the next few years, matrices are moving to the Algebra 2 level course, the 3rd year course. So you're going to probably want to get familiar with this as well. You can put in your matrix, tell it you want it to be, whoops. Tell it you want a new matrix. It's going to automatically label it A. Tell it how many rows and columns you want. Type in your entries. And then do all kinds of things with that matrix. I can find the inverse of that matrix if it exists. I can transpose it. I can enter a matrix for a system of equations. And tell it that I want to see if it'll do the reduced row echelon form for B. Hi, I'm leading a session right
because
now.
your ear, we have an issue here.
Okay, thank you.
Yeah, but I said I came to get A2, but 147. So that's why I said anything, you gotta give me that extra number.
Oh, okay, I'll remember that.
Huh?
Thank you.
I sent an email out, so I'm running around trying to get those numbers that are already sent.
Thank you. Sorry, that was our facilities director. She was checking on why the air wasn't working in my room. I apologize for the diversion. So my reduced row echelon form, I can get the solution to the system of equations. And if I want fractions instead, I can easily convert that to a fraction. I can create 2 matrices that can be added or multiplied. Tell it to multiply matrix B, sorry, whoops, get it back. B times matrix A. And I'm sorry, I didn't get my dimensions right. I need to do it the other way around too. Sorry. Matrix A times matrix B. And then it'll give me a solution matrix. So lots of tools there when you're doing that matrices unit. All right, that should bring us back to the timing that we set for looking at the graphing tools. So anybody who was exploring on your own, if you're back with us now, from here, you can just go, like, you can go from the Zoom screen and just start looking at your Desmo screen. You don't have to keep switching back and forth to the Zoom screen because everything else I'm going to be talking about should just show up on your Desmo slides without having to go back and forth. Sorry. All right, so the first thing we're looking at, the Zoom has lots of, the graphing calculator has lots of really cool features. This little drawing here and, reflects my artistic talent. So take that as you will, but I just wanted to show you there are lots of things students can draw. And there was actually a pretty cool Desmos art contest a couple of years ago. So sometime when you have time, you might want to just Google Desmos art and see some of the artwork that students came up with using the tools on Desmos, because it's pretty amazing, some of it. But just starting with that, one of the most basic things that Desmos can do is just plotting points. So you see, if you're on slide 14, you should see that 2 points, one labeled A and one labeled B, have already been plotted. So take a minute and see if you can plot the point 0, 0 and label it as C. So let me give you a minute for that. So basically you just type the ordered pair on the next line and then click the label and tell it what letter you want to label it with. All right, so it looks like most of you who are looking at that slide have correctly placed point C. And you'll notice if you click on the point, it will tell you, I saw someone do that as they were entering it. If you click on the point, it will tell you what the ordered pair is. All right, so that's just one of the most basic things you can do. You can plot points on the Desmo's calculator. You can also connect those points. So instead of listing the ordered pairs separately, I can make a table of ordered pairs instead. And then there are two ways to connect those points. One way is to press and hold the little circle next to the Y1. You have to press down the left side of your mouse, hold it down, and then it'll open a menu. And under that menu, you'll see an option that says lines. And if you slide the slider to activate the lines, then it'll draw lines between those points. Now, if you're doing that, what you'll notice if you do that for this set that's already here is that it'll draw the first two lines, but it won't complete your triangle. So if you're using that tool and you want it to complete the polygon, then you have to add an additional row on the table telling it to take 0, 0 back to 2, 3. So you'd have to put 2, 3 again at the bottom of the table. Let me give you a few seconds to play with that. Make sure you understand that tool. If you have questions so far, feel free to unmute and ask. Thank you, those of you who were monitoring the chat and helping out your classmates. I appreciate that.
I have a question.
Classmates, I should say. Yes, ma'am.
After 0, 0, I put in a new line and put 2, 3. Are the lines supposed to connect, or is it still supposed to be just like points?
Okay, to make it connect, if you see the blue circle up there besides the Y1, if you hover your mouse over that blue circle, you'll see a menu, like you have to press down on your left mouse key and hold it for a few seconds, and then a menu will open up. And on that menu, you'll see an option that says lines. And if you click on the slider beside the lines option, then it will connect your points.
Thank you.
You're welcome. Other questions up to this point? Okay. So the other way to connect it to create a polygon image is to use the polygon command. And if I'm using the polygon command, I don't have to put that fourth row with the 2, 3. So you've got that same table of values on slide 16 that you had on slide 15, but this time to create a polygon, go to the next line and just type the word polygon. And when you get to the end, you'll see it change from italics to non-italicized print. That tells you it's a command that you can use. And you're going to tell it to make a polygon with vertices that are the points labeled X1 and Y1. So you're going to type in your parentheses X1, comma, Y1. And once you type that, what you should see is that it just creates the whole triangle and shades it in. I'll give you a few seconds to try that, see if there are any questions.
I am still not getting how you're getting to slide 15 from 14.
There should be an arrow on your screen that allows you to proceed.
Okay, no, I meant on the calculator. I'm looking at 14. I don't know how you're getting the table. You said
I just re-entered it. To create the table. Thank you. Okay, gotcha. So if I want to create the table of values, the little plus key up there at the upper left of your menu, there's a plus key. If you click that, it'll say if you just hover, it'll say add item. And if you click on that plus, it'll give you some options. And one of those options is a table. And so whatever space you're working in, like it was the first line for me, it'll put a table in that space, and then you can add as many rows as you want to for your table. Did that answer what you were asking?
yes, ma'am. Thank you.
You're welcome. So, other questions up to this point?
Can you tell me how you got those points shaded again? On 16?
How I got it shaded on 16. So if you use the polygon command instead of the lines tool, like if you type in polygon and then tell it in the parentheses beside polygon to choose the values from the X1, Y1 table, so X1, comma, Y1, then once you complete that command, it will connect those 3 points and shade in the triangle automatically.
When I did that, it didn't create my polygon. I did that and it gave me an error.
All right, so are you on slide 16?
Yes.
So just making sure. Okay, so let me see.
Slide 15.
Oh, so you were on slide 15? You said? Okay, so on 15, if you had already put in the row that said 2, 3 to complete the circuit for the previous slide using the line tool, it might not be able to read it because you're giving it 4 points, but they're not different points. So you may have to take the 2, 3 back off if you added it to that row. Because with the polygon tool, you don't need that repetition of the last point to complete the circuit.
You're saying it's right polygon and parentheses X1, Y1 on slide 15, or am I on the wrong slide?
Let's see, so X1, well, we were doing it on slide 16, but it's the same 3 points, so it should work on either one.
It's not working for me. I don't know why.
But if I go up here and I put the 0.23 in, let's see if that still works. Yeah, it still kept it. The polygon X, are you putting a space or anything when you type the X1?
I shouldn't put in a space? Right.
No, that's what I was saying. You can just hit the letter X and the number 1 just back to back, and then comma, and then Y1.
Function N is not defined. I don't know what that error means. Function N is not defined is the error that I'm getting.
Okay.
Okay, I did it on slide 15. It actually worked perfectly.
Okay.
It doesn't appear to be working on slide 16 for whatever reason.
I found my error, guys. I had capitalized a P for polygon. That's a simple error that I made. Thank you.
Okay. Was there still a question or did you clear it up?
It was cleared up. Thank you.
Thank you. All right, so those are some of the things we can do to plot points. If you look at slide 17, we also have more options. So if you look at the little wrench key over at the right side of your graph, if you hover over that, you'll see graph settings. And if you click on that wrench key, you have the option to change your grid from a square coordinate grid to a polar grid. So those of you teaching about the unit circle might find that useful. That's also moving to the 3rd level course next year. So, that's the proposal anyway. It hasn't officially been approved. But you can use that, or if you're teaching about polar coordinates in your pre-calculus course, that gives you that polar option as well. All right, the next thing we're looking at as far as the tools is solving equations. And I let my students do this for solving equations last year, and they loved it. Obviously, we also want them to be able to solve things algebraically, but for those kids who learn very visually, sometimes this makes a lot more sense for them. For any kid, even if they understand the algebra, it gives them a way to check their answers. So if you look at slide 18, just looking at a basic equation, let's say I'm solving this equation, 2x plus 4 equals 16. I teach them to solve it algebraically by subtracting the 4 from both sides and then dividing both sides by 2, and I get the answer x equals 6. What they're seeing when they type that very same equation on the graph in that format is that x, the x coordinate, the vertical line x, they're seeing the equation of the line where x equals 6. So that's telling them the same thing that the algebraic process is telling them, which is that x must be 6 for this equation to be true. So that's one way to do it. A second way to do the same thing would be to put in the 2 sides of the equation as 2 separate functions. Like I could say, okay, I want to graph the line. If you're looking at slide 19, I want to graph the line 3x minus 4. And I want to graph the line 7 times x minus 4. I can put y equals 3x minus 4 and y equals, but I don't have to. So what I'm seeing here then is that it's graphing 2 separate lines. But if I find where those lines intersect, I'm still getting an x value of 6. So then I'm connecting solving a 1 variable equation to solving a system of equations, or to solving for f of x equals g of x when I move into those upper level courses. So they can approach it either way, just typing in the equation directly, 3x minus 4 equals 7 times the difference of x and 4, and they'll get that vertical line through 6, or that they can treat the 2 sides as 2 separate entries and get that intersection point. And you can walk them through making that connection even. Are there questions about the basic linear equations? Like how they could enter and solve those? Okay, they can take that skill and carry it through several other courses. So this might be an equation that they're solving in a middle school class. In Algebra 1, they can apply that same strategy to solve the quadratic equation. If you look at slide 20, you'll see a quadratic equation. It shows you that there are 2 solutions to that equation. One at x equals -2, one at x equals 7. Then they can carry that on into Algebra 2, where they're seeing radical equations, rational equations. I see the red on the radical equation on slide 21. That corresponds to the red solution on the graph. So x equals 10 for this equation. For the rational equation labeled in blue, I would look for the rational solution labeled in blue. So you can use it for those Algebra 2 level equations. With those more complicated ones, I can use it to illustrate very clearly that f of x and g of x are equal at the intersection point of their 2 functions, where x has a value of 2. Okay. So however complex I make it, I can still make that connection. And then on slide 23, you can see it even carries them into pre-cal with the trigonometric equations. And notice on slide 23, those of you teaching pre-cal or calculus, you can tell it to label using pi instead of using integer values. So like I set that when I created this, I went to the tools and I told it to count by pi over 12s. So every main line here on the graph is 1/12 pi. Are there questions about that? Okay, to make sure that you understand it, go ahead to slide 24 and just try entering an equation that you think students might encounter in the course that you're teaching. Okay, any questions about that? Thank you, Mr. Caraway. Yes, if I only want to see part of the function, you can limit it. So I could go back on, where did I find one where it was active? So like if I wanted to limit this where I was only seeing part of it, I could say, show me that function and then put in boundaries. Like I only want to see it where X is between 2 and 10. Something like that. And then if I'm looking at that particular function, I can see that it doesn't start until I reach 2 and it stops when I get to 10. So you can set those kind of boundaries too and do piecewise functions. All right, so that brings us to our next topic. The next ones we're looking at are looking at just function tools in general, things that you might be able to do with your classes for function tools. So on slide 25, you see we can just write a basic function. When you hit the y equals, you get the function, but it isn't necessary to put y equals. Like I could have just typed in the x squared plus 6x minus 16, and it still would have graphed the function. The only time it's necessary that I've found to put in a function is when you're doing a constant. Like if I just put 16, or let me do one a little lower down so it's easier to see. If I just put 2, for example, it's not going to automatically put the horizontal line. I would need to put y equals 2 to get that horizontal line, or f of x equals 2. But other than that, you can typically just type it in as long as it's a function in one variable. You can also use it to type in things like circular functions, or ellipses, or hyperbolas. And see the whole circle, where on a TI-84, using the function tools, you would typically have to enter the top half of the circle and the bottom half of the circle separately, since it's not actually a function. So you've got lots of options there for entering functions. So think about how you could use those kind of tools to help your students, instead of just telling them about features of functions or features of things like circles and ellipses. They could explore that for themselves. You could set up an activity that lets them do it. You could use it to do things like intercepts. Like if you're looking at slide 26, if you go to the graph and you hover over the intercept points and click on them, it will let you label those points. If you want to keep the label showing, click it twice. So you could set up an activity where you ask your students to label the intercepts, make sure they understand where the intercepts are. Okay. You could use it to illustrate transformation. So on slide 27, when you're looking at it. If I typed in this one, sorry, that should have given you the tools at the left, so I hope you're seeing the tools. But if I start with the basic x squared function and then I type in addition to that, the, yeah, it's not, I'm sorry if you're not seeing the tools for that. I will fix that before the next one, sorry. But if I typed in then, in addition to the x squared, there you go. Yeah, I'm sorry. Yeah, it was up there. If you type in x minus 3 squared and x plus 5 squared and x minus 4 squared, then you get this graph that shows you every time you add or subtract something inside the parentheses, the function is shifting left and right. All right, you could use it to teach them how to solve simultaneous equations, not just your systems of linear equations, but systems of quadratic and linear, or systems with an ellipse and a circle, anything like that. You can use it for simultaneous equations. You could have them click on the x-intercepts and the max and min values, and use those coordinates to identify intervals of increase and decrease, to identify intervals of positive and negative values, all of those characteristics that are listed in so many of our functions unit standards throughout the high school courses, and they're introduced to some of that with the linear equations in the middle school courses as well. So are there questions about that? All right, the next thing we're looking at is some of the data analysis features, and these are some of the really cool things. A lot of these same tools are available on the TI-84s, but sometimes they're a lot easier to use on the Desmo's calculator. So let's say I just have a basic data set. So I've entered a data set, I've labeled it as A equals this set of data. I could have typed in these 16 elements from my list. I could have taken my Word document where I have it listed, cut and pasted that whole list into there so I didn't have to type it. Those are options as you're going through to make it easier for your students. So take a minute and type in that you want, like type a line and type in mean, the word mean, and then put A in the parentheses. And then type in MAD and put A in the parentheses. And then my favorite one, put stats and type the A in the parentheses and see what happens. And for those of you who are still looking at some of the others, I'm on slide 30. All right, so hopefully you're seeing that when you put mean, now I could type in this whole list of 16 in the parentheses, but by putting it as a set A, that makes it easier when I want to do things with it. But there's nothing that's stopping students from typing in the whole list in those parentheses with commas like that. So it tells me the mean of the data in set A, 79.375. The mean absolute deviation for set A, 13.203 approximately. And then my favorite, the stats for set A, you get your whole 5-number summary right in one go there. So I think that's pretty cool. You can find these things separately and you can type in the commands, but if you don't remember the commands, you can also look at the keyboard, click on the keyboard, go over to functions. So there's a little keyboard symbol down at the bottom left of your graphing screen. When you click on it, it opens kind of your menu there. Click on functions over at the right and look under stats, and you'll see those different commands you can use. even cooler than how easy those tools are to use, if you'll look at slide 31, we've got this same set of data. Try typing in box plot and putting A in the parentheses. And then dot plot and putting A. And histogram and selecting the data set A. And on the histogram, you can make different bin sizes. If you don't enter a bin size, it'll make each histogram bar 1 unit wide. But if you wanted to say include from 0 to 5 in your bar, you could tell it to make it 6 units wide or something like that. So let me give you a few seconds to play with that. I'm not going to do all 3 for you, but just for any of you who are having trouble doing it on your own screen, let me just show you what happens with the histogram. All right. It gives me that, I'm seeing it really small, but I can go in. I need my x-axis to be pretty small, but my frequencies aren't that big. Change it where my y-axis has a different count than my x-axis. So if I click on that little wrench over at the right, then maybe I get a little bit better view of the bars. All right, and then another cool data feature it has, if you're teaching Algebra 2, you get to that unit where you're doing normal distributions. You can tell it the mean and the standard deviation for your normal distribution, and it will show that to you on the graph. You can also type in PDF for your set of data and CDF and get those values as well. The probability that it'll equal an exact value within your distribution, the probability that it'll be less than or equal to the value that in your distribution. So that's also a pretty cool tool. And we're getting short on time, a little bit faster, but I do want to show you this last data one. You put in a table of data, form your scatter plot. And I loved this when I found it. If you enter an equation using the tilde symbol instead of the equation symbol, you can put in the variable. So like if I want a linear equation in y equals mx plus b form, then I can enter y1 tilde mx1 plus b. And if you're looking for your tilde symbol, if you're on a laptop or normal computer keyboard, it's up there to the left of your numeral 1. I tell it to do that. It shows me my line of best fit on the graph. It gives me the m and the b values to write the equation for the line of best fit. And it tells me the correlation coefficient, so I can see how strong the correlation is for this line of best fit. And even cooler, not only does it do that for a linear, if say an exponential one, then I can put in an exponential format, AB to the x1. Right. Time. But you can do it with quadratics, you can do it with exponentials as well and find different regression.